Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about the chicken and rabbit method. Now this is a method for solving word problems, and of course the standard version involves some chickens and rabbits, which we'll see in a second, but it can also be expanded to a lot of other types of problems as well. Let's take a look here at our example problem. Let's do a pretty easy one to kind of start with here as well. So you're visiting a petting zoo with chickens and rabbits. Remember, quick biology lesson, chickens have 2 feet, rabbits have 4 feet. So that kind of is our setup for this here. And the important information we're given is that we count 10 animals and a total of 26 feet. So we want to figure out how many of the animals are chickens, how many of them are rabbits, and stuff like that as well. Now I want to point out at the beginning that this is definitely a problem you can do with algebra, right? Systems of equations and stuff. So if you want to write out equations like x plus y is 10, and then that is the animals, x chickens, y rabbits, so then the total number of feet is 2x plus 4y is 26. That is fine, right? But that's not going to be our focus of today. This method can actually be done for younger students who didn't quite learn algebra yet. But even for older students, this is a very quick way for kind of coming up with the answer as well. And once you get good at it, you can kind of do this in your head and come up with the answer quickly regardless. Now these numbers here are not big anyway, so either solving the system of equation, playing around with the number of chickens, number of rabbits a little bit, let's just get the answer out of the way here, right? You have 7 chickens and 3 rabbits. So if we wanted to double check this here, right, of course that's 10 animals. Every chicken has 2 feet, every rabbit has 4 feet. So here we have 14 plus 12 is 26. So this would be our correct answer. Everything kind of looks good in this scenario as well. Let's talk through, however, the method. So summarizing the question again, we had 10 animals and 26 feet in this case. And so I'm going to break down this chicken and rabbit method into a couple of stages here. We kind of have our initial guess stage, understanding this swap, which I'll explain in a second, and then once we're done with that, we of course have our final answer from there. So the initial guess you want to do here is a little bit counterintuitive, is a little bit weird. Typically, the initial guess for the chicken and rabbit method is a very bad guess, but it is going to make the calculations easier, right? So the initial guess here is all of one animal. So let's say we have 10 chickens in this case, right? So our initial guess is of course wrong, because if we have 10 chickens, then we see we have 20 feet in that case. So this is not the right answer there. But the idea is it's a very easy first guess, all of one type. We'll see in another method we can do kind of all rabbits. That's not going to change anything, of course. But we have this initial guess and we have an initial number of feet that we can kind of work with there. Now, our initial guess is wrong, of course, because we actually want 26 feet. But here's where we start seeing how this method is going to work, right? So we can say here that this guess is off by, right, 6 feet, right? We need 6 extra feet in this case. So the kind of idea here is we have our initial guess, and then we kind of say, how is it right? How is it wrong? Well, we have the correct number of animals, but we need 6 extra feet in this scenario? Well, rabbits have more feet than chickens. So the swap stage here is kind of what happens if we change a chicken into a rabbit, right? So here, right, just typing this out here a little bit, right, we're kind of understanding we swap one chicken for one rabbit. Or we want to kind of start understanding what happens in that scenario, right? What happens if we swap a chicken for a rabbit in this case? Well, this is going to give us plus 2 feet, right? A rabbit has 4 feet, a chicken has 2 feet. So if we turn a chicken into a rabbit, swap a chicken for a rabbit, we get 2 extra feet. Well, how many extra feet do we need? We need 6 extra feet. So 6 divided by 2 is 3 swaps in this case. And so this is now how we start understanding our method. And hopefully you'll kind of see that this stuff can definitely be sped up as you get good at it. So we start with 10 chickens, so that's 20 feet. This is off by 6, so we make 3 of these swaps. So this ends up with 3 rabbits, right? We made 3 of these swaps, so we have 3 rabbits in this case, and we have 7 chickens. This is of course the same answer we got before, as expected, but it's good to kind of see it here with this initial guess. How far are we off? Then we make swaps to fix our answer, and then that gives us our final answer pretty quickly from there. Okay, so let's take a look at this with some different numbers, right? So what happens if we have 42 animals and 142 feet? So these are bigger numbers. We have to kind of do different things that way, but let's kind of practice this kind of as well. Right, so let's do it here with an overestimate of the feet to start. Let's start with 42 rabbits in this case. So if we have 42 rabbits, right, so they're all rabbits here, well, we're going to have 42 times 4, right? Each of those things has 4 feet. Each rabbit has 4 feet. So we have 168 feet in this case. Right, and so this time we're doing an overestimate, right? So this is 148 minus 142 equals here 16 extra feet in this scenario. Now, we can do the same thing except kind of swapping the other direction here. So if we swap a rabbit for a chicken, right, this removes 2 feet in this case. And whoops, let me correct my extra here, right? This is of course 26 extra, not 16 extra. So 26 extra feet in this case there. So that's kind of what we have then in this scenario. So our initial guess gives us 26 extra feet. We're making swaps to remove 2 feet. And so then what does this give us here, right? This means we have to do 26 divided by 2 equals 13 swaps. So we have 13 swaps. So what does this give us for a final answer? This gives us for a final answer then we have 13 chickens. And the remaining animals, right, so we have 29 rabbits in that case. So, right, 13 chickens, 29 rabbits, and that's kind of our method. So 168 feet if we have all rabbits, that's 26 extra feet. Every swap from a rabbit to a chicken removes 2 feet, so we do 13 swaps and end up with 13 chickens, and 42 minus 13 is 29 rabbits in this case. Now, If this could only do questions about chickens and rabbits or only questions about animals, right, it wouldn't be that helpful in some cases. So let's look at another example that can be done that is a little bit different. So here we have a motion example in this case. So Greg is going on a hike. I'm going to kind of highlight all of our important information. Greg went on a 10-mile hike last weekend. The hike was very hilly, so he's always hiking uphill or downhill. Going uphill, he hikes at a speed of 2 miles per hour uphill, 4 miles per hour if he's going downhill. And we're given that the hike took Greg 3.5 hours in total. So we want to figure out how many hours are uphill and how many are downhill in this case. So we can see pretty quickly, I have the important information summarized here, but we can kind of see how this is related to that chickens and rabbits. Right? We have this information, it's 10 miles in 3.5 hours, and we know he can go 2 miles per hour uphill and 4 miles per hour downhill in this case. So, right, let's look at, as our initial guess, now let's say he's doing just all of the hiking uphill, right? So let's say we have 3.5 hours uphill. So if he's going all of the time uphill, this will tell us he goes, right, 3.5 miles or 3.5 hours uphill and 2 miles per hour uphill. So this is 7 miles in this case. So he's going 7 miles if he's only hiking uphill in this case. Now this is wrong, right? We need, this means, 3 extra miles. Right? He didn't walk enough. His hike wasn't long enough. It was only uphill, right? It's not long enough based on the kind of speeds and distances he's going in this case there. Now, in terms of the swap, this is a little bit different. But what happens if we swap 1 hour of uphill and we turn that 1 hour of uphill into 1 hour of downhill? So this again is, right, a swap that's not changing the number of hours, right? If we swap an hour of uphill hiking for an hour of downhill hiking, he's still hiking the same number of hours. But since he goes 2 miles per hour faster, this does give us 2 extra miles. So here's how we can kind of be thinking of these swaps and stuff as well. Now, we already have it in the problem, but it's worth repeating that half hours, fractional hours are fine here, right? So how many swaps do we need, right? In this case, we're going to swap, well, we need 3 extra miles. Every swap gives us 2 extra miles. So we need to swap 1.5 hours in this case. And so that seems a little weird with our kind of decimals and fractions here, but that's totally fine, right? This means that he ends up hiking 1.5 hours downhill. So we have kind of the hours downhill in this case. So, and how many hours up? Well, it's the other 2 hours in this case. So 2 hours he is hiking uphill from there. So 1.5 hours downhill, 2 hours uphill, and we can see that this question is also kind of answered using this chicken and rabbit method. If you liked this method, right, check back each Thursday for a new math tidbit in 2021. We have a lot of daily math practice as well on our Zoom International ZIML.areteem.org site, including some problems hidden in there that you can solve using this chicken and rabbit method. So I hope to see you guys there as well. If you liked this video, please let us know by subscribing and hitting the like button below. And otherwise, I will see everybody next week for our Thursday tidbit. Goodbye.